Welcome to this video on increasing and decreasing functions using calculus. We've got our general rule just in the box here. We know that f dash of x is the slope. So obviously this is saying if f dash of x is greater than 0, that means if we have positive slope, that f of x is increasing. And if we have negative slope, when f dash of x is less than 0, then the function of x is decreasing. So let's begin here with the function y equals x take 2 squared. And we should know from year 11 that we can just look at these functions and identify the periods when it is increasing and decreasing. So basically you just got to imagine yourself as a man walking along the curve. And here you're walking downwards if you're walking along the curve, okay? So the function is decreasing. But then we get to this value 2 where it's touching the x-axis and you start walking upwards. So it's increasing for that period. So just from looking at the function, we should be able to say that it's increasing for x is greater than 2. Now we always use greater than or equals to. The reason for that will become clearer later. And decreasing for x is less than or equal to 2. Okay, you can see if you're walking along here, it's decreasing for those values. And if you're walking up here, it's increasing for those values. So that's what we learned in year 11. What we're going to learn this year is how to use calculus to do it. So the first thing I'm going to do is find the derivative. So remember we have y is x take 2 squared. So to find the derivative of this, we need to use the chain rule. So dy on dx will be 2 times x take 2 to the power of 1 times the derivative of the inside, which is just 1. And let's expand this out. That'll just be 2x take 4. So this is the equation of a line. So let's think about its graph. Okay, 2x take 4. It has a y-intercept at minus 4. So let's say there, minus 4. And it has a slope of 2. Now, when does it cross the x-axis? So it crosses the x-axis when y is 0. So that's when 2x take 4 is 0. 2x is 4. X is 2. So it crosses the x-axis here, 2. So if I draw this graph, okay, this is the graph of dy on dx. Let's label our axes. And now we're going to just draw the sign diagram of that. So if you remember, the sign diagram just tells you where it's positive and where it's negative. So it's above at 2, so we've got positive, and it's below for values less than 2, so we've got negative. And so what we're doing then with this calculus is we're using the sign diagram to tell us when the function of x is increasing and decreasing. So from here we can clearly see the same results we had before, that it's increasing for x is greater than 2 because the slope is positive for x is greater than 2. Remember, this is the sign diagram of the slope. So positive slope for x is greater than 2 and negative slope for x is less than 2. So it's decreasing for x is less than 2. So that's the basics of it. Now let's get into the examples from the notes. So if we look at the first example, this was an accident, but it turns out to be the exact same function. Okay, so let's just outline the process that we're using here. We're deriving it. We've got 2x take 4. If we graph the function, this is what it looks like, and its sign diagram correspondingly looks like this. And hence we know because the slope's positive for values greater than 2, it's increasing. And the slope's negative for values less than 2, so it's decreasing. And of course, with these graphs, you guys will love this, you can just use your calculator. Okay, and I'm actually going to teach you a super cool trick right now for our next problem. So if we've got b here, let's sketch the graph of it. So I've got x squared take 5x take 36. Now we should know how to sketch the graph of this. We know that there's going to be an asymptote at minus 2, okay, because the denominator is 0. And if we were to factorize the top, we'd have minus 9 and positive 4. And so the roots are going to be 4 and 9, minus 4 and positive 9. So let me just show you what it factorizes to be so you can see what the roots are going to be. So it'll be x take 9 and x plus 4 on top of x plus 2. So we'd have asymptote at x is minus 2. And we have roots. Now roots occur when the numerator is equal to 0, so that would be positive 9 and negative 4. So we've got the function there. That's just the main function. Now, if we were to derive this one, we're going to have to use the quotient rule. Now, I do expect you to be able to do that. Of course, we've learned that in the last test, but this is where I'm going to teach you a little bit of a trick, particularly when it comes to graphing the derivative function. So if I just exit out here, now follow along here, we've got the main function there, that's f of x. Now, what I'm going to do is I'm going to press option and calc. And up comes all these different things that we can calculate. We're going to calculate d on dx, so that's f1. And we're going to calculate the derivative of y1. That's all we need to do. And what that's going to do is that's going to draw the graph of the derivative function for us. Now, because I've got an old calculator here and the colors are just black and white, it can get a bit messy. So here's another trick, is the select button, that's F1. If I go up to the first function and press select, it's going to unselect it. So now it's not even going to graph y1, it's only going to graph y2. See how it's got the black highlight there? So if I were to unselect it, it's not going to graph anything. I just want it to graph the derivative function because I don't want to have all these lines going everywhere and it be a bit difficult to read. So it's not even going to graph the first function there. So I press equals. If you've got an old calculator, it will be a bit slower. Okay, so again, we can see from the graph here, we've got that asymptote at minus 2. That's going to stay the same because we know the derivative of this function will be on top of v squared. So the denominator is still going to be minus 2. And we can see all along here, there's no real roots. So what the sign diagram looks like then is we have an asymptote at minus 2. And it's positive to the right of minus 2. Okay, we can see it's completely above the x-axis to the right of minus 2 and completely above the x-axis to the left of minus 2. And just keep changing your v window to make sure, you know, if we were to go out to 100, and we can see, and it's going to take ages to draw because it's even got a bigger v window this time. But another way to check is if you try and g-solve some roots, and it's not going to find any roots for me, okay? Because it doesn't have any roots, that means it's completely above the x-axis. So that's one trick we can use for some of these harder ones, all right? But you still are expected to know how to do that kind of stuff manually, as in the previous example. So then let's state the intervals where it's increasing and decreasing. So this is going to be increasing for x is greater than 2. Now this is the only case where we don't use greater than minus 2. This is the only case where we don't use greater than or equal to because it doesn't exist at the asymptote. The function is undefined. And then decreasing for, increasing for x is greater than minus 2 and x is less than minus 2. Okay, we're never decreasing, it's only increasing for x is greater than minus 2 and x is less than minus 2, but it does not exist at x is minus 2, so it's undefined at that point. All right, let's have a look at our last example. So we've got y is e to the power of x. Now obviously dy on dx is just going to be the same function, e to the power of x. And we know that e to the power of x never crosses the x-axis. So even the derivative function is just going to have a sign diagram like this. Okay, no asymptotes, no roots, it's completely positive. So the way we'd answer this one is that it's increasing for all x. And so the way you've got to solve these problems, first step, find the derivative. Second step, draw the sign diagram of the derivative function. Feel free to use your calculator. And because you're going to have your calculator for the rest of all the tests that you do and the exam, so you may as well just use it. And then state the intervals where it's increasing and decreasing. Okay, fundamentally it comes to if the slope's positive, then f of x is increasing. If the slope's negative, then f of x is decreasing. So a fairly easy concept today. Good luck with it.